All right, so hexadecimal. This is not part of the AP exam. However, it is incredibly useful within the computer science career field. And a lot of it comes down to the fact that with hexadecimal, or I'm sorry, which stands for base 16, it's easy to take 1 byte and write it as just 2 digits. And the reason for this is that 16 is the same as 2 to the 4th. And if you remember, a byte has 8 bits. Well, 4 of those bits will be 1 digit in hexadecimal. The other 4 bits will be another digit in hexadecimal. So I had said when you're dealing with binary, base 2, you want to write out your 8 bits. And to write underneath those, your powers of 2. If you have to work with hexadecimal, what I would recommend, so hexadecimal, which is base 16, this means that we're counting powers of 16. So I wouldn't write this part as part of scrap work, but it means that here, these would be 16 to the zeros, which are 1s. These would be 16 to the first, which are 16. If I had a third, this would be 16 squareds, which is 256s. And so that's what you have to notice, though, is after just, by the time we get to the third digit, we're dealing with how many 256s fit inside the number we're talking about. That's big. Ancient Babylonians used this because they were dealing with astronomical numbers, like I mentioned in class. So it allows us to write large numbers in very few digits. In the case of binary, I'm sure you've noticed, it's really annoying if you want to write or talk about a byte. Saying all those 1s and 0s, it's very hard to keep track of. It's very easy to lose your place. It just takes a long time to say them. So in shorthand, computer scientists will say the hexadecimal because the change between binary and hexadecimal is not that bad, but we'll get to it. One of the things that does come up, though, is the digits. So in binary, we could use 0 or 1. In decimal, we can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In hexadecimal, we have to have 16 possible digits because let's say there are 14 ones that we want to talk about. Well, I cannot write a 14 here because that's more than 1 digit. So what we do is we have our normal digits that we are used to. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, like we're used to. But I can't write 10 because that's now 2 digits. I still need 1 digit. So what we do in hexadecimal is we use capital letters. And we say, well, then 10 is going to be A. 11 is going to be B. 12 is going to be C. 13 is going to be D. 14 is going to be E. And 15 is going to be F. This, if you are working with hexadecimal, I would write this. So write this when working in base 16. So what we can get is some weird stuff. We can get things where we'll get numbers that are written as OCF in base 16. This means that C is, there are 12 16s and F is 15 ones. Now I could sit there and try to figure out what is 12 times 16 and then add 15 ones to that, but there are faster ways of doing this. So on the next page in OneNote here, there's a link to a video. The guy has a very heavy New England accent. Enjoy it. He talks fast, but his method of converting hexadecimal is incredibly easy to do once you know what to do. So this video end, go and watch this video, and then watch the third video, which is going to be me working through a couple of examples.